Hello, and welcome to today's webinar, Miniaturized Solutions for Battery Development. I'm Amanda Hosey, your moderator for this 60-minute program, which focuses on highly integrated and optimized battery management systems. Our speakers today are Boris Kitcher and Davide Scucimara of TE Connectivity. At TE, Boris is a global product manager for global automotive battery solutions who focuses on module-to-module and cell-to-cell connection. He holds a bachelor's degree in industrial engineering and has more than 9 years of experience in automotive relays, terminals, and connectors. Davide serves as an account development manager for electric vehicles at TE, where he focuses on applications related to EVs with a primary focus on powertrains, batteries, and auxiliaries. Davide holds a master's degree in mechanical engineering and has more than 10 years of industry experience. If you have questions for our speakers, please send them to the Ask a Question box and we'll address as many as possible at the end of today's program. Also note that a PDF of slides may be downloaded under the Event Resources tab on screen. Now, on to the presentation. Welcome, Davide and Boris.
Hello. Thank you very much for joining this webinar. So, as anticipated by Amanda, this webinar will focus on battery management system and the connectivity solution that at TE we can propose for this kind of application. In this webinar, we will provide an introduction about the e-mobility market and the trends that are affecting this transportation segment for us. And then we will we provide an overview of the battery pack in order to show all the subcomponents that are affected and managed by the battery management system. And then we will go to explain the main role of the battery management system, which are the main functions, and relating to the main functions, which are the main challenges that this kind of application gives to our products. So at TE, which kind of challenges and which solutions we provided to overcome the challenges that this application provides. Then my colleague Boris will provide a specific and specific presentation about the solutions for battery connections with a wide product range that at TE we can provide. And then in the latest section, we are open to questions from your side. So, as indicated, from a market point of view, we know that this is a period of deep transformation for the transportation segment. This affects all the mobility market. Trends like sustainability, digitalization, and mega cities are influencing the mobility market and all the requirements that are related to these mega trends. In particular, the main drivers that are affecting the mobility are related to the reduced emissions that are necessary from the society and the regulation in general. The drivers are also requesting a higher range of autonomy for electric vehicles, and also at the same time, OEMs need to have clever solutions that can cope with the long-term reliability and value for the new electric vehicles. These new requirements can be reached with new generation components that must meet higher voltage transfer and quality. And at TE, we can provide a wider range of products that cover all the applications related to the mobility. We go from the charging inlet to the high voltage connection system and to the specific battery solutions that we will show in this webinar. As indicated before going in details with the battery management system application, we want to show a physical representation of a standard high voltage battery in order to show all the subcomponents that are related to the functioning of the battery management system. So in the standard high voltage battery, we start from the battery cells that are the active material inside the battery. In the cells can be of different shapes, like cylindrical, prismatic, and pouch, and are organized in modules, as indicated in this picture. We know that the latest trends that OEM are having are with or modules, or even without modules, with higher integration of cells inside the pack, or in addition inside for the complete vehicle integration of the cells. The second component of the high voltage battery is the cell management controller, that at the end processes the working parameters of the cells and translates the physical signals to the digital ones. The cell management controller communicates with the battery management controller, that we show later, and the communication is essential to guarantee the proper working parameters for the battery cells. The third component of main component of a high voltage battery is the battery disconnect unit. That is the main function of the battery disconnect unit is to switch on and off the battery in the different operating modes. In practice, it manages the high current paths between the battery and the other electrical systems. So for both charging and traction paths, the battery disconnect unit makes the connection between the battery. The latest and the main element for the high voltage battery, that is also the core of this webinar, is the battery management controller, that is the brain of the BMS, of the battery management system overall. In practice, the battery management controller processes the inputs that it receives from the cell module controller showed before, and it guarantees that all the working parameters of the cells, like the current, the voltage, and the temperature, are inside the working parameters in order to let the battery work in the defined range of defined by the requirements. This is essential, this activity of this function of the battery management system, in order to ensure that the battery works without having shocks and ensuring the higher durability of the battery, to ensure that it operates for the entire cycle life of the battery. At the end, the role of the battery management system is resumed in the monitoring of the main parameters, as indicated before, like the voltage, temperature, and current, and the other functions related to the battery management system, related also to the estimation of the parameters like the state of charge, the state of health, and ensure that, based on these calculations, activate the cell management controller and let the cells operate in the correct ranges. The battery management system is also working in terms of preconditioning, so it warms or cools the battery in order to influence the temperature and let work in the correct parameters. There is also the communication between the BMS and the battery disconnect unit in terms of contactor switching. So, based on the working parameters, the activation or deactivation of the battery is done through the battery disconnect unit showed before. This at the end, so we have the first 4 questions based on the application as indicated before. So I leave to the presenter for the 4 questions. Okay. So I see that the first question was answered by the audience. So there were indications about also high wireless solutions from the audience, at least 10 users, I see. So what we show, so I go back to the presentation. All these working parameters and the function that the BMS has translates in challenges for the products, for the connectivity products that as TE we must provide for our end customers. In particular, from the physical representation of the battery that you saw before, you can understand that the compact and lightweight requirement is crucial for the connectivity solutions that we must provide, but they must cope also with the requirements of ISO 26262 in terms of clearance and creepage. So this is a criticality that we face with our products and we aim to solve, and we provide specific solutions for this kind of requirement of compact and lightweight. So we developed miniaturized connections up to 1.27 millimeter of pitch, and also solutions with flat cables and flexible print cables with FSC and FPC. This because, as you saw in the previous representation of the battery, also the space in height is limited by the geometry of the battery. So we foresee that also higher usage of these solutions can be required by the market. In addition to that, there are also higher temperature ranges that are needed to be met, together with higher flammability rates. So we developed specific products that can withstand with this kind of environment. So we go in details later with my colleague Boris that will show the specific solutions we developed, but we have in mind all these challenges that we aim to solve with our products that will be shown soon. I leave the space for the second poll question, and after that I leave the space to my colleague Boris. So we can see the results. So also now is still proceeding the answering. So you confirm, the audience seems to confirm that it is a fixed requirement, the V0 flammability rate. In any case, for most of in most of the cases is a fixed requirement.
Okay, thank you, Davide, for the very interesting presentation. Then I will take over for the portfolio part, for the products by themselves. Today we are talking about the miniaturized portfolio. When we're talking about miniaturization, we're talking about miniaturized signal interfaces. And these miniaturized signal interfaces having a big role in the battery architecture, especially for the cell management and battery management systems, as my colleague Davide mentioned before. What are the main drivers here in the market for the signal interfaces in general when we're talking about miniaturization? Because not the only thing I would say for signals is the battery. Of course, it's a huge portion in the vehicle, but we are also playing in other areas. First topic is space and reliability. Also in the battery, we see that we're having lots of application, lots of signals from the battery cells which need to be monitored on a regular way. And also, when we're talking about the complete energy density of the battery, it's very important. Space is also a really small resource in the battery. That's why we are having also space requirements in this environment. And then, of course, weight and sustainability. Smaller interfaces allow, on one hand, smaller products, less copper weight in the vehicles, and also less space on the PC boards. That means also reduction of the weight, which end up directly in a reduction of electricity which is needed for the vehicles. And of course, the reliability. TE has experience since decades for connection systems, and this complete knowledge we also using in the products which we are promoting for the battery architecture. And last but not least is, of course, the automation readiness. I would say the battery is a product in general, which is made for automation. We have a clear cluster here, clear structure, and that's why it's also very important that we are even on the smallest, on the signal terminal level, ready for automation. I would like to go shortly together with you in the overview and the history about miniaturization. For signals, we started with the MQS portfolio. I would say it's globally, meanwhile, state-of-the-art of signal interfaces in automotive application. The first step of our miniaturization is around about 10 years ago with our NanoMQS product for unsealed application and the M0.5 portfolio for sealed application. This first round of products allowed already a space reduction of 50%, and the second round, or the high-end product of our miniaturization, is the PicoMQS, which allow another space reduction of 40%. That you get the feeling a little bit what this 40 and 50% means, we're having here pictures on the right-hand side in this chart, where you really see the size difference when you use a different product. Just to summarize it shortly, the products we are using in our portfolio for battery application, first one is the PicoMQS. We got also from an American platform an award for this innovative product, which was officially launched last year to the market. But we are already for VW since many years with the MEB battery in the market, and rolled this product family also now out for the general market. Then the NanoMQS, which is also in lots of battery applications for BMS and cell management systems in the battery in usage globally. Then we're having the NanoMQS with flat foil cables, so that you're using the same terminal system, the same contact system, where you have the electrical performance and the mechanical performance. The only difference is that we have here at the end, where you usually have the crimp for a wire, that you have to crimp for a flat foil or a flat printed cable. Then on the other side, the ERNI MicroBridge is also a very space reduction concept. We call it ERNI MicroBridge because it was developed by ERNI, but ERNI was, I think, 2 or 3 years acquired by TE, and now we are on the way also to integrate this portfolio. The main difference here to the Nano or PicoMQS family is that they have an IDC wire termination compared to our products or standard products which are working with crimp areas. Then the ERNI Voltron is similar to the MQS high voltage sensing detector, a detector which is made for the high voltage area of the signals in the battery or the high voltage areas in PC boards. That means you can use the same terminals like for standard MQS. The difference here, or the driver, is that we're working with much bigger pitches to match the requirements regarding air and creepage distances. Let's go maybe a little bit more in detail into different products, starting with the PicoMQS. I think the most important is that we can decrease the pitch on 1.27 millimeter. And we know that in several applications, the battery systems, we are going to higher pitches, even up to 3 millimeter. The reason behind is our specific requirements in the battery, mainly driven due to air and creepage distances. But the big advantage here in this Pico system is that it is around about 4 millimeter shorter compared to the NanoMQS, which allows also further reduction in the battery application, depends on the orientation of the header. Performance-wise, it's quite important to say that we are capable up to 4 amps. The limitation by it is not the terminal by itself, it's the mating wire, because this terminal is capable for 0.22 square millimeter wire sizes. And we're having also now new an FFC terminal released, which can be also purchased for FFC application on PicoMQS footprints. And last but not least, we're having here, as mentioned before, the 1.27 millimeter pitch, which is more used in black box application, but we're having also other products which are at the moment mainly restricted, but we have also some general pitch sales products which pitches up to 3 millimeter. The NanoMQS product is the bigger product, the big brother of the PicoMQS. Here, the minimum possible pitch is 1.8 millimeter, and it's capable for wire sizes up to 0.35 square millimeter. What's also quite important, the current carrying capacity is up to 6 amp, but also here, not the terminal is the limiting factor, it's the wire by itself. We're having here different platings on this terminal family, tin, silver, and gold. And of course, I forgot to say it, for the PicoMQS, we have here a complete automotive specification behind. According to the LV214, it was released, but meanwhile, it's also matching the new product specs of the major OEMs and on the MEA side. And also on the US side, the colleagues set up further tests for NanoMQS to prove that such products matching also the US Car 2 validation requirement. What's quite important, the differentiator between PicoMQS and NanoMQS is on one hand that NanoMQS has a CPA, which we don't foresee in PicoMQS because it's too small, too tiny to handle it on a smart way on PicoMQS, but on NanoMQS it fits very well. And we're having a quite complete header portfolio with 90 and 180 degree orientation header. The ERNI MicroBridge, I mentioned 1.27 millimeter pitch. That means it's the same size like the PicoMQS pitch-wise, but the big difference is that it has an IDC connection compared to our wire termination on the core products from TE Connectivity. The IDC connection allows more flexibility regarding the orientation of the products. That means we can do the cable exit as shown in the picture on 90 degree orientation, but also on 180 degree orientation, or if needed to 90 degree orientation to the other side. That means when you have really up to the space requirements and need a specific orientation, which is maybe not possible with a standard crimp product, the ERNI MicroBridge would be the right one. Performance-wise, they are quite similar. The ERNI Voltron, as mentioned before, it's a standard product with crimp terminals, but the difference here is mainly the pitch sizes that to reach the air and creepage distance, which are required for high voltage applications up to 1000 voltage, is the air and creepage distance increase, and this ends up in a bigger pitch. The same for the NQS high voltage sensing detector. It's a similar, different design, like different application specification is behind, but also here the difference with standard NQS is really the increased pitch size. Let's take a look in the battery application in the FFC overview, what we have already, and on the next page, what we plan for the future. We have at the moment in the market the NanoMQS FSC. The terminal by itself is capable, and the connector also, for FSC or FPC wires. For the termination process by itself, it doesn't matter which foil is used. The terminal by itself is capable for both foils. We're having at the moment a top edge portfolio in the market with H2032 position. We're having also some Z0 header available because we know from some customers this Z0 topic is a requirement. Other customers don't want to see it at all. That's why we're having here some products already in Z0, but not all of them. Next to the standard NanoMQS, we're having also at the moment in the ramp up the PicoMQS for flat foil cables, which has the start of production this quarter, so end of this calendar year. And here we still need to identify the right products for our customers since we're having here just the market launch for the FSC based on PicoMQS. And the second big part of our portfolio is the NanoMQS 24 to 48 position. It's validated against the LV214 based on a specific plating on the header side. We can match here also the mating force requirements according to the LV spec on 214 Newton. And what's also quite interesting that we're having set up one interface for round wires connectors and for flat foil connectors. So both fits on the same interface. Especially what I learned in previous discussions from the market that quite often they know the pinouts, the interfaces, but not sure if the future will be on round and or on FSC wire. And here it would allow, even in late stages of the development, to switch just from round to FSC wire since we're having here one header interface on the other side. Okay. Then I would like also to discuss or to show shortly that we are not just considering our NanoMQS crimp version or PicoMQS crimp version for FSC and FPC connection. We are also having here a roadmap behind and developing ourselves in many different areas. I go through those different concepts shortly. But the main message here is that you get an understanding when you're having a need for specific FFC solutions, FFC, FPC connectivity. We would like to be your partner here. Even if you don't see your preferred concept here on those maps, but please contact your counterpart to learn more, or that we can learn from your side also what is needed in future generations regarding FFC, FPC technology. First topic on the left-hand side, we're working here on a preloaded system for welding termination. The welding is more focusing on aluminum wire termination when the customers want to change from copper to aluminum conductors. We're also working on a piercing concept. The ease of assembly is here the focus, that a foil can be just pushed in the connector. The connector can be pushed down, and then there's a wire termination. Also, what we are working on specific ZIF connectors or non-ZIF connectors because we know here's a big benefit, ease of assembly, lower cost, because we're just talking here about a simplified four contact or not about a system with terminals, connectors, and header. And also the ease of assembly is in the focus here, but we know also that standard ZIF concepts from the market, which are showing up from industry and some customers also considering or considered to use it or even not to use it in the automotive world because they have not the same quality regarding the contact resistance, regarding the power supply, but also regarding vibration. Because we're having here a complete different environment compared to other industry products. That's why we look in here in the ZIF concept, which allows the benefit of a ZIF with the ease of assembly, but also provides the reliability which is needed for automotive application. About the Pico NanoMQS crimping, we talked about. We have the Nano already running in the market. The Pico is coming up. And also below preloaded for welding, we're having the idea to clip the foil, but also some concepts here, which are in the very early stage for super flat connectors, because the question is really, when we have such a flat foil, why should you set up such a thick connector at the end, which is again space consuming? That's why we're really working here in various different directions. And would be happy to learn also more from your side about the needs, the future trends, which you see for FSC application, and maybe where you have problems to find the right termination to the foil, to the BMS or CMS system. Okay, then we're coming at the end to the poll question, to the last one. Okay, thanks for answering such poll questions. And with this question and the answers, we are also through the webinar. Thanks a lot for having the chance to provide the portfolio we are using for signal interfaces in battery. In case of any questions, feel free to contact us directly, or your sales partner from TE Connectivity. Also, thanks a lot to my colleague Davide, who made a great overview about the application structure and gave us some very interesting insights of the battery application.
All right. Thank you so much, Boris and Davide, for that presentation. And just a reminder to the audience, you can still submit questions for our speakers through the Ask a Question box on your screen. Now let's take some questions that have already come in. First up, what do you see, where do you see the market and trends for the future of the EV battery?
Okay, for this question I can answer. So regarding the market trends, we must divide between the several components of the battery. We can say that for, as anticipated before, for the cells layout, we see that the future batteries of electric vehicles will have a structure that reduces or even eliminates the number of the modules. So the solutions we showed before was the current one for the current platform. So the cells that are structured in modules that compose the battery pack. In the future, we see that already from next generation of OEM platforms, we have the cell-to-pack layout from the OEM. So we have no more modules, but one single module that compose the complete battery pack. So these have implications. So with less connection module to module, we have the removal of all the connections that currently are present from module to modules. And so the higher integration of the cells inside the pack. So in practice, there is more active material, more cells. And so in this way, OEMs can reduce the number of interfaces, so less components, less weight, less cost, and enlarge the autonomy of the car. The other trend that we see in terms of battery is also a higher integration inside the battery of auxiliary modules that at the moment are foreseen to be external, to be present as external to the battery. For example, the onboard charger and DC converter, we see that the next platforms, some OEMs are considering to include inside the battery and make integrated versions, like the BMW one or the VW one. So we see this trend of higher integration inside the battery pack. This higher integration, for sure, stresses the necessity to have miniaturized solutions, not to have also for the connectivity. We put also in the poll questions the info about the wireless BMS, so the transmission of the information wireless. We see this trend, but not upcoming. So we can also check with not the audit that confirm this trend in their projects. So we can also make an alignment offline to see if there are pre-development projects, because this is a trend that we are monitoring, but we don't see active in the next platforms that are ramping up are in SOP in the next couple of years. But we know that there is also the wireless solution is a trend that can also spread for the BMS. So we are keeping under control also these. So these are the main trends for the new generation of batteries, I would say.
All right, thanks so much, Davide. Next up, what is a battery management system, and what are the components and/or key requirements for a battery management system in EVs?
Yes, in practice, we showed during the webinar what we can assume that the battery management system is the combination of the battery management controller and the cell module controller, and these are the main components that compose the system, the overall system. And the function is to keep all the working parameters of the battery inside the specific range of operation. The requirements that we see for the battery management system are related to be compliant to the ASIL-D in terms of engineering, to comply with the ISO 26262, also in terms of clearance and creepage values for the connectivity, from what also Boris indicated during the webinar, and also the requirement that battery management system must comply is to ensure that the working parameters of the battery are constant during the car lifetime, that is estimated in 15 years. So these are the main requirements for the battery management system application, let's say.
All right, thank you so much, Davide. What are the advantages of using an FFC or FPC connection over a round wire connection? And also, which connection or connector system technologies for FFC or FPC are available and under development?
Yeah, I can answer this. Boris speaking. The main benefit is here on one hand a little bit more space, because it's flat foils, reducing also here the space compared to the round wires, but the main driver here is automation. When we're thinking about the future trends, as Davide mentioned, that we're having less modules, but much bigger modules. That means also in one module, we have a higher number of cells. And each cell needs to be monitored by a signal contact. And that's why we're talking the future architecture, not more about 20 to 30 pin positions. Maybe we're talking more about 6 to 80 in one connector. And it's much easier to assemble and to automate a foil, which is 60 conductors, or with 2 times 30 conductors, compared to 60 single wires. That's why really it's a big advantage for the ease of assembly, for the automation, to use this flat foil cables. Which products do we have? We mentioned already in the presentation up front that NanoMQS is already rolled out in the market with the FFC crimp, and we have now the PicoMQS also ready for the market. And in the development area, we're working on welding solutions in-house for FSC foils, but also for clamping and ZIF concepts for FSC. That's it
All
from
right,
my
great.
side.
Thanks so much, Boris. Thanks, Boris. Next up, someone asks, will there be solutions to support IP67 or IP69K sealing requirements?
First of all, we must say we have products for IP67 sealing requirements. It's the Encon 0.5 portfolio, but we have also some dedicated products in NanoMQS for sealed application. The issue is that we are talking here about the battery by itself, and the battery shouldn't be in a wet area. Yeah? So there's no reason that battery should be in. I know that some customers are afraid of dropping condensed water, but when we are discussed this with them at the end, they refuse the sealed versions because they are more than double sized compared to a standard Nano or PicoMQS. What normally nobody's using in battery application, sealed applications. At the end, at least this is what I can say on the MEA side in Europe. What I saw where I was in discussion with lots of customers, even it was discussed previously, but at the end it was not used. Only thing I could see that one customer was a little bit cautious about this dropping condensed water, which could happen in theory by their risk analysis, that they choose in the last generation of battery a cover on top, which should give them here a little bit protection, but not for a complete sealed system, and also for the next generation. I see that this cover is already not really anymore in the focus. I hope this answers your question a little bit. It's possible in theory, yes. We have sealed application products, yes, but at the end, it doesn't make really sense from our perspective to use such expensive and over-designed sized products for the battery.
All right, great. Thank you so much, Boris. The next question asks, considering the upcoming zone ECU concept, do you see standardization of vehicle connectors being common so that the connectors would be a brought out part?
We, yes and no. What we would like also to implement here for the ECUs standardized interface. It would make the life much easier for everybody in the market, I think. But at the end, each OEM is deciding by themselves if they want a standardized interface or not. Yeah, we're trying with our TRIO portfolio to push here a portfolio to the market which is using existing terminals, that we just need to modify the connector system by itself. It's a quite good idea. From some customers, they like it. Other customers just want their own interface. That's why I expect inside one OEM group, yes, they will go for defined interfaces, but for the complete market, I see it too diverse at the moment, that they could align on one dedicated interface for ECUs.
Yeah, and they would also add that for the specific application of BMS, we have requirements that are pretty specific, like with zero requirements, clearance and creepage that are must comply with pollution degree up to 3. So it's not so common to have this kind of requirements in other zone ECU that will be present. So it will be difficult to have the same to standardize completely the portfolio for from this BMS application, let's say. So we were also thinking about developing a specific product family, or at least solutions that are aimed for this kind of application.
All right. Thank you, Davide and Boris, for that. Well, with that, we have reached the end of our webinar. I would like to thank Davide Scucimara and Boris Ketcher, as well as our audience, for joining us today, and thank you to everyone who submitted questions. We'll supply the speakers with any we didn't get to so that they can follow up later. As a reminder, you may download a PDF of today's slides under the Event Resources tab on your screen. In just a moment, a survey will pop up. Please tell us what you thought of this program by answering 3 quick questions. This webinar will be available on demand, and an email will be sent to everyone who registered as soon as the archive is ready. Once again, thank you all for watching.